Steady, go.
Hello.
Hello, Mr. Aaron, Mr. Ryan. How are you today? Good.
Hello.
Good. Okay. So
God.
we have talked about counting the number of the 1 bit in each integer in the binary, right? For example, 15 in binary. What's that?
1, 1, 1, 1.
1, 1, 1, 1. Yeah. Yeah.
Yeah.
How about 8 in binary?
1, 0, 0, 0.
Well done. Yes. So basically we count one. There will be 4 and there will be 1. Yeah. In binary. Yeah. Okay. Do you still remember how we counting it? Define, count 1. Yeah. N. Yeah. Do you still remember how do we count it? One easiest way will be use the Python's function called bin. Bin. Yeah. Bin is short for binary, not for the rubbish bin. Okay. Binary. Yeah. So what it takes the number 15, a number. Yeah. Then you will give this will give a string. Look, it has two extra bits. It's 0, 0 binary, and then 1, 1, 1, 1. So basically, you will have prefix the actual binaries with 0 bit. Okay. So then we can count the bit. How can we do this? We can first of all convert this n. Yeah. Yeah. But we don't want this number 2. Yeah. These 2. Yeah. Yeah. We can just do this. 2, then you get rid of this. Or we don't need to get rid of it. And then after that we do what? Count 1. Okay? That's it. Yeah? Do you still remember, yeah? Okay, so that's the knowledge.
That looks pretty short.
Yeah, pretty short. So this converting numbers to binary. Yeah, converting numbers to binary is log n, right? Yes? And then counting.
Log n.
Counting usually is O(n), but n is the number of bits. But when you count it, convert it to binary, the n is actually log n. So actually the count number of 1 is log n times log n. Do you get it? Oh. Do you get it? Because this counting 1 in the string is O(n), right? Is O(n). But this n is the number of the bits, which is O(n), O log n in this case. Yeah. So actually it's O log n. Okay. So this is not the fast.
N times log n.
Yes. Okay. So now we can do another one. Remember? Define. Let's do another version. Count 2. Okay. N. Come on. Look. 1, 1, 1, 1. So every time. We can, yeah, look, every time we can count, we can look at the last digit, yeah? And if it's 1, I add it. If it's 0, I add 0. And then I get rid of it, and then it becomes 3 digits. And then I look at the last digit. Least significant byte, okay? Bit. So it's last digit. And I look at it, I take away it, I look at it, I take away it. So we can do this.
You run that.
Look, answer equals 0, while n bigger than 0, answer plus equals n. The last bit is n and what? What's the last bit? N what? In the last bit, 1, yeah? Do you still remember? And then I want to remove the last bit. How can we do it? We can do this. Shift to equals 1, yeah? Or you can do this. Divided by 2, yeah? Divided by 2. Divided equals 2. Okay, it's the same thing, yeah? This divided by 2, the integer part, is same as in the binary. You shift it as 1 bit. Okay, so look, what's this mean? Alright, 1, 0, 1, 0, 1. When you do this, n is this one. When you do this, and shift equals 1. Shift to the right 1 position. Why is that? You shift 1 to the right. What happened? The rightmost 1 gone. Then it becomes that. And you shift 1 more. The last 0 gone. Okay? Yeah? And if it is the opposite way, yeah, it shift to the left. What does it become? You put a 0 at the end. And do it one more time. Put a 0 again. Okay, how about this? Eric? Shift equals 2. What happened?
You shift.
You put 2 0 at the end. Easy?
Yeah.
And how about this? And shift equals 2. What does it become?
You shift.
You take away 2 zeros. Easy? Yeah? So this means I take away 1 digit at the end and I add it. If it's 1, then it's 1. If it's 0, it's nothing. And return what? Return what? Can you guess? Answer. Well done. Okay, so this is one way of doing it. The other way is what? Define. Let's do it count 3.
What's the complexity?
Complexity, good answer. It's log n. Yeah? Is it log n? Look, because if n is 15, then log n is 4. You only have 4 bits, 4 iterations. Yeah? Because every time I take a bit in the binary, I cut it out. And how many times I need to cut for 15? 4 times. Am I right? Yeah?
Yeah.
So log n. Okay, how about this count 3? Instead of
Are we just going count 4, count 5?
no.
Six.
Look. 1 0 0 0. Look. This is 8. Yeah. Okay.
Yeah.
Do you need to take away 1 0 0 0? We don't, right?
Yeah.
Because we know it's 0. It doesn't matter, right? How about we just take away the rightmost one? Yeah. If we take the rightmost one, we add 1. Do you get it?
Yeah.
Okay, so then look, how do we take away the rightmost one? Remember, Eric?
You just do the opposite.
No, look, 1 0 0 1. How do we take away the 1? Eric? Remember, we talked about this before, right? Look, how do we take the 1? If we minus 1, that will become 0 0 0 1 1 1. Yeah? If we minus 1 from this minus 1, it will become that, yeah? Alright? In binary, yeah?
Mm.
And then we end. We do this end. Logical end. 0 0 0 0 0 0 1. Got it? So basically, if n, you want to take away rightmost n, you will become n and n minus 1, right? So in short, you write n equals n minus 1. It's the same thing, okay? So every time we take away the rightmost one until it's 0. So it's quicker, right? It just look at this 1 first. It doesn't look at each digit. It skips the digits. Am I right? Yeah? So look, this is useful. If we want to check the power of 2, if number is the power of 2, remember we talked about this before, 8. Yeah?
The power of 2.
8, look, if it's the power of 2, 2 to the power of 3, yeah?
And it's a 1.
It only has 1, yeah? It only has 1, right? It only has a single 1 in the binary. So it will be n minus 1. That will become 0, right? Do you get it? If it's 16, 1 followed by 4 zeros, the same thing, right? I mean, look at this. This is 2 to the power of 4. 1, 2, 3, 4. It's 16 in binary, right?
Yeah.
So what n minus 1? What's n minus 1?
N minus 1.
0.
1. 1, 1, 1.
What's n? What's n? What?
N is 0, 0, 0, 0, 0.
It's 0, yeah? Only when it's n, it means if both number is 1, it's 1. Otherwise, it's all 0. Okay?
What happens if both are 0?
Sorry?
What if both are 0?
0. So it's only 1 when both sides are 1. Okay? All other three cases 0. Okay? But for the all, it's different. It's 1. One of them is 1, then it's 1. It's 1 0, 0 1, or 1 1 is 1. For all, yeah? Eric or Ryan, yeah? One of them is true, right? Eric and Ryan, both of you needs to be true. Then be true, okay? It's same thing, this is logic, okay? Okay, so this is also O log n, right? Yeah?
Yeah.
Okay. Now, suppose we have these functions already, okay? So now, given a number n, okay?
Yeah.
Now listen carefully, given the number n, and I want you to find out. I want you to print out a list of integer containing the number of bits for the all numbers between 0 bigger than x, okay, bigger than 0 and smaller equals n. So this is given. For example, this is when n is 3, okay. So now I want you to find all the numbers between less than 3 or equals 3 bigger than 0. So it will be 0, 1, 2, 3, yeah? Yeah? And then I want you to give me an array containing the number of ones in each digit. So 0, that will be 0. 1, that will be only 1, yeah? 2, how many ones in 2?
2.
How many ones in 2?
0.
1, 0 is 1, yeah? How many ones in 3?
0.
No.
1.
What's 3 in binary? Look, 0, that's binary. 1, 1, 0, and what's next?
1, 0, 1.
1, 1. Look, you always increment the last thing. And what's next?
1, 0, 0.
And what's next?
1, 0, 0, 1.
What's next?
1, 1, 1.
Sorry?
1, 1, 1.
And what? No, 1, 1, 0. Come on. You add the 1, and then you carry over, it'll be 1, and this becomes 0. And what's next?
1, 1, 1.
Okay, and what's next?
1, 0, 1. No, 2.
0.
1, 0,
There's
0,
no
0.
2 binary.
1,
So
0, 0, 0.
well done. And what's next?
1, 0, 0, 1.
What's next?
1, 0, 1, 0.
1, sorry, 1, 0.
1, 0.
What's next?
1, 0, 1, 1.
What's next?
1, 1, 1, 1. No. 1, 1. 0, 0.
What's next?
1, 1, 0, 1.
What's next?
1, 1, 1, 0.
What's next?
1, 1, 1, 1.
Okay, let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah? You see? Got it?
Yes.
Yeah, now, it's basically the same as like 9, what's next? 10. Yeah? 99, what's next? 100. Yeah? And you make mistakes on this. 101 plus 1. 101 plus 1. You say it's 111. It's not true. Look, 1 plus 1 equals 0. Carry over 1. So it's 110. Okay? Got it? Okay. So look. So given a number n, and then you find all the number of bits between the number 0 to n, right? How can we do this, Eric? Eric? You can just write the loop, yeah? Answer equals 0. And then look, for I in range 1 till n plus 1, yeah? And then I can just say the answer dot append. Alright?
Yeah.
Count. Yeah, we just use the count. Count I. That's it. And return answer. What's the complexity?
O N log n.
Sorry? No. Eric. Look, Eric.
N log n.
If it is count, no. Yeah, we if you're using the first count, what's the complexity? Don't look at my notes. O n log n. Why is O n log n? Can you tell me?
Is A N log n.
Can you tell me why? Can you tell me why it's O n log n?
Range. For the
Look,
first
this one.
Talk O n log n.
Look, this one is O. You need to understand, not reading my notes. Okay, O log n. Yeah, this one is O log n. Yeah. Yeah, because we talk about that. Remember O log n. Yeah. At least there's a loop n here.
Yeah, that's
So-
exactly what I was talking about.
So O n log n. Yeah. Alright.
Yeah.
Yeah. How we can we do better? One hint. Dynamic programming. Do you know dynamic programming?
Dynamic.
Programming. What's dynamic programming? Can you tell me? What's dynamic programming?
Is remembering.
Remembering, yeah. So do we need to count? Look, we are counting all the bits from the number 0 to number n, right? Yeah? Listen. we are counting the numbers, number of bits from number zeros to number n. Do we need to count every number?
Yeah. No.
No, we don't have
Not
to.
every time.
Look, if we know, look,
If you know we have 5
yeah.
apples, if someone
Look,
gives
look,
us
look.
1 apple, we'll just do 5 add 1. Easy.
yeah, look, what's this in binary?
That is in.
Well, in decimal, it's a plus 4, yeah, it's 12, yeah? This is a, this is 4, yeah? This is 2, this is 1, right? This is 12. So, and what's this in what's this in what's this in binary? 8, yeah?
Yeah.
Binary, that's 8. Okay, so 8.
Plus 1 that equals 3.
Okay, and 12.
Plus 1 equals 13.
So if I tell you, okay, if I tell you 8, if I tell you 8 has only one single one, okay?
Have only 1.
Yeah?
There it is.
Yeah, you don't need to calculate. I already give you that F8 is 1. And then, you know 12 is one single bit after one single bit more than 8. Yeah? So F12 is what?
2.
2. And that will be F8 plus 1, right? Yeah? Do you see the problem? Dynamic programming. Do you get it?
Yeah.
So the basically is like how do we get the right rightmost bit? Rightmost bit. Look, Fn equals Fn. If we get rid of rightmost bit, that will be this. Yeah, we talk about that. Yeah, look, what's this? 1 1 0 0 minus 1 1 0 1 1. Yeah.
Yeah.
What's the answer?
The answer is 0 0.
Sorry?
1 0 0.
1 0 0. Okay, so look, Fn, I get rid of rightmost bit, and then that will be. What should I do here? What should I do here? What's the answer? This is f is the number of bits for the number of integer n. And then if I get rid of rightmost bit, I get rid of 1 bit. And what should I do here?
You should.
F12 equals F what? 12 minus this is 12 and n and 1. N minus 1 is this is 11. This is 11, yeah?
Yeah.
And that will be this will be 8, yeah?
Yeah.
F8 what?
F8 is 1.
Is 1? Plus 1, come on. Got it?
Yeah.
So every time we want to calculate Fn, we get rid of the 1 in binary. Just erase it, becomes 0, right? And this Fn and n minus 1, we already calculated before, right?
Yeah.
And then what's the difference? What's the answer difference? There'll be only 1 difference, yeah? Because I get rid of 1 and I need to plus 1, yeah? Do you get it?
Yeah.
Okay, so now we can write this. Look, define. Let's do this f. Okay, n, and then I do this answer equals because the first wall is 0. Okay, then I can do this for I in range n plus 1. Yeah. Alright. Look.
Yeah.
Answer I equals what?
I equals.
Answer what? Remember what should we do here? And here, there's something here, and I can return answer here.
Plus.
Yeah, and then this bit.
Answer
This is
n.
this is I. There's no n here. This is I. And what should I do when I?
N there.
Yeah, I know I is from. Actually, this is from 1 to n plus 1. So I will be from 1 to n, right?
Yeah.
Okay. So please. So I want to get rid of the rightmost 1.
You shouldn't have this.
Yeah, I want to get rid of rightmost 1. What should I do? I what?
In range.
I minus 1. What's that?
I minus. I.
Not equals. Come on, I talk about that all the time. 12 becomes 8. What 12? How does 12 become 8?
You take away 1 bit.
1 bit. Okay, so how do we take a 1 bit? And what? Come on. Look, 12 is 1100. I take away 1 bit. I minus 1. What's 12 minus 1? Is 11, right? In binary, it will be 1011, yeah?
Yeah.
And then if I do this n, it will become 1000. Okay?
And.
So that's how we took the 1 bit. Yeah? Got it? Do you remember now? So this, where should I put it? What should I put it? I?
And.
And?
No,
I?
minus 1.
Yeah, come on, it's here! What you looking at? What's the complexity?
Oh.
What's the complexity?
N.
No, there's no count here. Oh, there's only one.
Log N.
Oh, n, just oh, n, because we have only
I
one
just
root.
said O-N.
Yeah. Okay.
Yeah. You said no.
Okay. I didn't hear you. Okay, look, answer. We can also do this. Look, there's only one. There's another way. Yeah, Eric, look. Look. This is taking the 1 bit. Yeah, taking the 1 bit, they'll become 1
Whoa.
1 0 Yeah. You take away the rightmost 1 bit. Yeah. How about I can do this? How about if I take away the rightmost bit? You become 110. Okay? This is the same. So answer I equals how can I take away the rightmost bit?
And.
No, I remember I was shifting, yeah? Right 1, yeah? Yeah?
Do you need the equal?
No, because this is just the evaluation. I take away the rightmost bit, I shift it to the right, yeah? But how do you know if it's the rightmost bit, you need to add it 1 or no? If it's 0, we don't care. If it's 1, we need to add 1, right?
Mm-hmm.
So plus, what should we put plus here? We know plus 1 because it might be 0. So how can we check? We need to check I, the last bit of the I. If the integer n, what's the rightmost bit? How can we get it?
We need to and.
And what?
I. No, N.
And what? The last bit. Look, it could be this. And how can I get the last bit? I can do this. Yeah?
Yeah.
Look at this. What's this number?
That's 1.
1. Look, if it's 1, the last bit is 1, then it's 1. If it's 0, then it's 0, right? If it's 1, it's 1, yeah? All other bits are 0 because I have 0 here, yeah? It doesn't matter if it's 1 or 0 because if anything and 0 is 0, yeah?
Mm-hmm.
Okay, so and 1, right? Yes? Am I?
Yeah.
So look, this one will be n and 1, right? Does it make sense? I want to calculate the number of bits in I, yeah? Then I can calculate, because I already calculated, this number is smaller than I, right? Because I take away the last bit, this number is always smaller than I, am I right? Yes?
Yeah.
If I take away 1 digit, the last digit of 8, what will it become in binary?
4.
Yes, we are done. The 4, I already calculated. And then, but the answer, the 1 I need to take away, I don't know if it's take away 0 or 1. And then I can do this n1, right?
Yeah.
How about 5? Look, Eric, 5 is 1, 0, 1, right? 5.
Yeah.
I take away 1 bit, that will be 1, 0, that will be 2, right? But the last bit is 5. 5 and 1 is 1, right? And I need to add 1 instead of 0. And 1, yeah? Got it? What's the complexity for this one as well?
N. Log.
Don't say log n.
N.
Just on, come on, it's the same.
No.
Yeah? You're not thinking when you talk about the log n, okay? When we the
I
first
said
one
they
is
went
log
at
n
the
because of the count.
beginning.
Yeah, okay.
I did they went at the beginning.
Okay, that was correct. Well done. Okay, because we're using the count function, which is log n, right?
Yeah.
Yeah. If we're using the count the first one, remember the bin function, then the complexity will be
Finally.
on log n log n. Am I right? Yes.
But,
So what's this algorithm? Dynamic.
programming?
Why is it dynamic programming? Because
Memorizing.
we memory. We want to calculate the
Memorization.
memorization. Look.
Memo.
Okay, so one question: is this top down or bottom up?
Top down.
Top down, yes. You can do it bottom up, but this problem is better to be solved using top down because the bottom up you need to start from 0, 1, and then you'll be less intuitive as top down because look, we want to calculate I, then we can solve it. We can update the value. We can calculate the value based on the smaller problem because we already know I shifted 1 or I take away the the rightmost one. I already know the answer for a smaller problem, smaller integer, right? Yeah? And I already know that. So this part I don't need to calculate it again, right? This is the magic. This bit, I already know it. I memorize it. I don't need to calculate it again. And then the new answer is just +1 or, yeah.
Mm-hmm.
Do you see how it works?
Yeah.
Yeah? Okay, good job today. Okay, good job. Good job, good job. Do you have anything to say to the people over the world? Okay, you say bye. Ryan, you want to say something? Okay, then see you tomorrow, okay? Bye bye. Goodbye. Bye bye.